Teledyne Ryan Aeronautical is a company of products. Teledyne Ryan Aeronautical is a company of aerospace firsts. Teledyne Ryan Aeronautical is a company of capability. The Teledyne Ryan Aeronautical main plant, located on a 44-acre site adjacent to San Diego International Airport, this complex is headquarters for aeronautical engineering and design, with adjoining production facilities for prime or subcontract aerospace manufacturing. In the early 20s, flight was still in its infancy when T. Claude Ryan founded the Ryan Aeronautical Company and later accepted the challenge of building Charles Lindbergh's Spirit of St. Louis, a great technological achievement in its day. Throughout the following half-century of aerospace progress, Ryan became known for many firsts in the industry, such as vertical takeoff and landing jet aircraft, pilotless jet targets, and remotely piloted vehicles. In 1969, the company became Teledyne Ryan Aeronautical, a wholly owned subsidiary of Teledyne Industries of Los Angeles, California. Teledyne Ryan's acknowledged leadership in unmanned aircraft technology was established more than 30 years ago with the Fire-B-1 subsonic jet target. Fire-B has proven itself to be a highly reliable aerial target for training the personnel of the free world's armed services and testing the sophisticated air-to-air and surface-to-air defensive equipment they man. To date, more than 6,000 Fire-Bs have flown over 30,000 missions, with a mission reliability factor in excess of 92%. Fire-B's performance envelope includes a maximum speed of Mach 0.97 in level flight, altitudes in excess of 18,000 meters, and a maximum endurance mark of nearly 2 hours in its standard configuration. The target can be launched from sea or land-based stationary and mobile zero-length launchers. Fire-B can also be air-launched for greater flexibility in conducting remote testing or training activities. Fire-B's highly modular design allows it to be adapted to a variety of missions, or to provide a wide spectrum of realistic target simulation through radar augmentation, chaff dispensing, and infrared augmentation. The basic design has undergone various aerodynamic and structural modifications for up to an 8G turn capability. Although originally designed with a J69 engine, Fire-B's performance capabilities have been enhanced by modifications that accommodate the more powerful J85 as well as other potential engine options. Supersonic threat simulation approaching Mach 2 is the role of Fire-B-2, the first of Teledyne Ryan's supersonic target vehicles. Longer, leaner, shorter winged than its predecessors, this high-performance jet target attains speeds, altitudes, and G maneuvers that put present-day weapon systems to the test. The third member of Teledyne Ryan's supersonic target family is the Firebolt, which is being developed under prime contract for the Air Force's high-altitude, high-speed target program. Firebolt's small size, just over 5 meters in length, facilitates air launch from standard fighter aircraft. Carried on the center store position of an F-4 Phantom, the Firebolt drops away at a typical mission launch speed of Mach 1.5 at 15,000 meters. An onboard automatic flight control system provides a highly maneuverable and versatile flight program, including constant Mach number and altitude cruise, constant G 180-degree and S-turns, as well as climbs and dives. Firebolt's extraordinary performance, including speeds up to Mach 4 and operational ceiling of over 30,000 meters, provides a realistic replication of aircraft and missile threats for decades to come. With Firebee-1, Firebee-2, Firebrand, and Firebolt, Teledyne Ryan will be able to provide target vehicles that match the performance capabilities of any known airborne threat into the next century. Overlapping speed-altitude envelopes illustrate the wide range of these parameters, which will extend from subsonic flight at very low altitudes through the supersonic region at extremely high altitudes. In addition to its long history of jet target development, Teledyne Ryan has also designed and manufactured an entire family of remotely piloted vehicles, or RPVs. These robot aircraft are employed where conditions such as a hostile environment, very low or high altitude, or long endurance flight would be too expensive or too hazardous to include humans. Since the early 1960s, over 900 RPVs in 30 different configurations have been developed to fulfill three basic mission requirements: photo reconnaissance in both day and night and at high or low altitudes, electronic countermeasures, including both passive and active systems, and radar and communication signal intelligence gathering. These RPVs have also demonstrated the possibility of strike missions with the on-target delivery of the SPASM self-propelled air-to-surface munition. The stubby Hobos television-guided glide bomb and Maverick television-guided missile. Launched in the same manner as aerial targets and recovered by parachute with an airbag impact attenuation system, or retrieved in midair by helicopter, these RPVs provide the tactical commander with a versatile and flexible system that will allow him to dispatch a vehicle at short notice from almost anywhere. The 124R is typical of the Teledyne Ryan RPVs, designed for photo reconnaissance at both low and medium altitudes under hostile conditions. Capable of flight as low as 50 meters and speeds up to Mach 0.95, the 124R has the maneuverability necessary to penetrate enemy defenses and the reliability to achieve its mission objectives consistently. Operating ranges extend from 800 kilometers at extremely low altitude to 3,000 kilometers on a maximum range mission. Interchangeable nose configurations can accommodate various high-resolution camera systems for low or medium altitude photo reconnaissance missions. A prime example of Teledyne Ryan's design, engineering, and development ability is Compass Cope, an advanced state-of-the-art high-altitude, long-endurance RPV capable of runway takeoff and landing, either manually or automatically under onboard computer control by following tactical landing radar beam and radar altimeter data. It set the unofficial endurance record for RPVs in 1974, when it remained airborne for over 24 hours. Teledyne Ryan is well equipped to develop the next generation of RPVs with emerging mission requirements of speed, low and high altitude, short and long duration for both one-way and reusable systems. The company's staff of research, application, and design engineers are skilled and experienced in low and high altitude, subsonic and supersonic aerodynamics, propulsion, structure designs, and avionics integration, and are complemented by the necessary computer facilities, engineering test laboratories, and flight test and operational support expertise. Their talent has been utilized on many programs to perform engineering studies, such as the development of flight control laws for the NASA HIMAT program through advanced flight control simulation, a kind of wind tunnel in the sky approach. The technologies of flight dynamics and simulation developed for the evaluation of such programs, Teledyne Ryan's role as an aeronautical manufacturer is a matter of record. Over the years, thousands of jet target aircraft and RPVs have been produced, and during its history, Teledyne Ryan has also been a subcontractor to each of the major airframe manufacturers, producing assemblies and components for aircraft such as Northrop's F-5 series and F-18 Hornet. As a team member of the Hughes Helicopters Company, Teledyne Ryan has the responsibility for manufacturing the airframe for the U.S. Army's Advanced Attack Helicopter, the AH-64. This major production subcontract includes the fuselage, empennage, wings, engine nacelles, avionics bays, and canopy structure for this rugged frontline gunship. Under the direction of Hughes Helicopters, Teledyne Ryan participated in the engineering design of the airframe and manufactured 8 sets of prototype airframe assemblies that were used during the development phases. While most of the aircraft is of conventional metallic construction, approximately 170 parts are made from a fibrous, reinforced advanced composite. The company has been a pioneer in the development and application of composite materials, including Kevlar and graphite epoxy, a technology called upon by Lear Avia in the manufacture of the prototype Lear fan. Teledyne Ryan's manufacturing capabilities are one of the most comprehensive in the aerospace industry. Numerically controlled machining, as well as conventional machining, tool design and fabrication, welding and brazing, metal processing, metal forming, non-metallic fabrication and adhesive bonding, and assembly, all part of a total engineering, design, and manufacturing capability. Capability, however, is more than facilities, processes, and technological hardware. It's people. Human resources, nurtured and developed over more than a half-century of aerospace challenges. Teledyne Ryan Aeronautical is indeed a company of capabilities.